everyone, it's Justin again. In this lesson, you'll learn about the angle and arc measure relationship that exists when an angle is inside a circle. Be sure to complete the angles inside the circle discovery activity before continuing on with this video. Pause the video now so you can complete it. By the end of this lesson, you will be able to calculate values for angles inside circles. First, we're going to learn about the formula that relates the measure of an angle in a circle to its corresponding arc measures. Next, we'll explore how this is related to the measure of the central angles of a circle. And finally, we'll complete an example problem. You may have noticed that this lesson's title sounds pretty similar to the previous lesson. In the previous lesson, you learned about two chords intersecting on the circle, like this. But in this lesson, you're going to learn about two chords intersecting inside the circle. The activity you just completed was a great way to see this concept in action, and maybe you even figured out the relationship we're going to be using in this lesson. The goal of the discovery activity was to figure out a relationship between the measure of an angle inside the circle and the two intercepted arcs that fall in between the same two chords that the angle does. Were you able to figure out a relationship between these three measures? Hopefully, you figured out that you can add the intercepted arc measures together and divide by 2 to get the measure of the angle. For example, if these are the intercepted arc measures that relate to our angle, we can add them together and divide by 2. 100 plus 78 divided by 2 is 89. And that means that this angle measure in the circle is 89 degrees. And since vertical angles are congruent, this angle here is also 89 degrees. Believe it or not, we've already been working with a result of this relationship throughout this unit. Think back to the central angle. How do the central angle and the intercepted arc measure relate to each other? They're equal. The reason this is true relates to the formula that we just came up with. Let me show you how. If we extend these radii out to become chords, you'll notice that these chords are special since they intersect at the center of the circle. They're actually diameters. Can you relate this picture to the new formula we're learning about in this lesson? Well, these angles and arc measures equal each other. Let's say their values are 25 degrees. Can you figure out what happens if we substitute these values into the formula? The intercepted arc measures get added together and divided by 2. And that just gives us 25 again as either of these central angle measures. It's interesting to see that something we've been using throughout the entire unit is actually a result of this equation. Now that we understand our new formula and have even analyzed how it relates to the central angle concept we've been using quite a bit, let's take our new knowledge and apply it to a practice problem. This problem says to solve for the value of the unknown variable. Take a moment here to organize the information and see if you can make a plan for solving this problem. Okay, let's go through this together and come up with some options for finding the solution. Ideally, we would know both of these arc measures and we could just add them together and divide by 2, and that would give us the value of x, but we don't have both of these arc measures. So what can we do? Do you have any ideas? There are 2 ways you could approach this. The first is to subtract all of the other arcs from 360 to see what's remaining for this unknown arc measure. Now that we know this arc measure is 50 degrees, how would you finish solving this? Hopefully you said that you would add 50 and 100 together and divide by 2 to get that the value for x is 75. Now that's one way to approach this, but perhaps you thought of another way. The second option is to use the values of these two arc measures, insert them into this equation, and get a value of 105. But how does that value help us solve for x? Well, it represents this angle. And how is that related to the angle containing the variable x? The angles containing x and 105 are a linear pair, which means they add up to 180. Solving for x by subtracting 105 from both sides of this equation gives us 75, just like we got with the previous method. Now you know how an angle measure inside the circle relates to the two intercepted arc measures. Be sure to keep the other concepts from this course in mind, like the fact that all the arc measures add up to 360, vertical angles are congruent, and the angles in a linear pair add up to 180 degrees. With all of this background knowledge, you'll be able to reason your way through the practice problems. See you next time!
Hey!